Hello and welcome back. Sorry about the interruption. We're having a lecture for year 12s and year 13s about how to use these special rules for general solutions to trigonometric equations, and I got interrupted by an Amazon delivery. And it's actually not that bad because I'm glad I actually left this particular question, because this is actually a 5-star question. It's actually enrichment, purely enrichment, and perhaps I shouldn't have actually included it with the stuff I was doing on the last lecture. So this is 5-star, and we tried to solve this particular equation, and we're not allowed a calculator. We have to actually solve it just purely by using tricks and understanding. And of course here we do have a clue. I did mention, of course, it's got something to do with this. All right, so what's in this equation? First of all, it's in degrees, and I like degrees because we have better intuition about things. We have double argument there, not double theta if you want, triple there, and of course on top of that we got shifts on both of them, and the different shift as well, 20 and 50. We got a sine and a cos, not even the same. I mean, by the way, just for, I would have loved to have had in there, for example, the sine of 2 theta plus 20 plus the cos of 2 theta plus 20. By the way, this particular equation would have been suitable for year 12s because we can create a tan of 2 theta plus 20, but that's wishful thinking. We don't have nothing like that up there. So what do we do with something like this? Okay, let's clear that line that I've just written. That was on my wish list, and I don't think I'll be getting my wish list this year for this, but I'm going to do the following. I'm going to separate sides, and the question is, which one do I make negative? And I'm thinking a little bit far ahead with this particular one. If I have a minus in front of the cos, I cannot easily hide that minus inside this argument because cos is an even function. However, if I have a minus in front of the sine, I can put the minus inside the sine because sine is an odd function. So with that in mind, I'm going to leave the cos of 3 theta plus 50 on the left, and I'm going to take the sine to the right hand side. And of course the next step is a follow-up, because I explained the rationale for doing it this way is to actually move that negative inside the sine. So the minus will go now the sine of minus 2 theta minus 20, and that's because, let's put degrees there, and that's because sine is an odd function. The problem that I'm having now is this: if it was cos is equal to cos, you've seen that in my previous lecture, I'll go to this. If I had the sine is equal to sine, similarly I would have gone to rule number 1. So here, how do I approach it? Okay, there is another identity. This, I can't remember what it's called, is it complementary identities for sine and cos? I can't quite remember what they are. They're symmetry of the graph, and you can easily verify that from your compound angle. There's two symmetrical identities that they basically say, I'm going to do it in degrees since we're in degrees in there, that the sine of A or the cos of A is identical to, let me move out of the way, the cos of 90 minus A, and if I have a cos, it's the sine of 90 minus A. And this allows you, what's the purpose of these identities, is to switch between sines and cosines. You can easily verify that even with a right angle triangle, but of course with a right angle triangle, you're just basically saying this is holds for A being an acute angle. But in general, if you use your compound angle here or there, you'll verify these two identities. So I'm going to use it now for this particular equation. The question is, which one do I change? Do I change the cos or the sine? It will hardly matter. Let's change the sine. So I'm going to leave the left hand side as cos 3 theta plus 50, and now this will change to a cos, but if I change to a cos, I'm going to put a square bracket. I need 90 minus the argument of this sign. So it's going to be 90 minus -2 theta minus 20, close round bracket, close square bracket. I'm going to do a little bit of a tidy. The cos of 3 theta plus 50 is equal to the cos. Let's do the theta bits first. So I'm going to have a 2 theta first of all, minus minus, and the degrees, the number bits, is a plus there, so plus 110 degrees. So at the moment this is looking good because of course I got cos of something is equal to cos of something else, so I can jump to the general solution. I covered a few questions of this type on the last time we visited this particular topic, and basically what makes this 5-star is to see all of these steps and get to this particular form. So let's set up a general solution now. Let's do it from the left. So 3 theta plus 50 and 3 theta plus 50 again, equal and equal. Principal 2 theta plus 110 with repeats, we're in degrees, multiples of 360, where n is 0, 1, 2, 3 and so on, dot dot dot. And the secondary for a cos is 360 minus this quantity here. So 360, let's write it down so we don't make mistakes. 360 minus 2 theta plus 110 plus or minus 360n. And we gonna tidy up a little bit. I'm gonna do it in one step, I hope. So looking at this equation, 3 theta, take away 2 theta, I've got theta on the left. And for the numbers, I've got 60. 110, take away 50, I got 60 with repeats of 360. Did I put solution interval? Yeah, it's 0 to 360 for this one. And for the other one, the theta has a minus. So when I take it to the other side, it's going to be a 5 theta altogether. And my numbers now, I'm going to have 360, take away 110, 350, 250, and then take away the 50 from this side is equal to 200. Again with repeats of 360. From this line, I merely need to just recopy this just to divide this by 5. So I'm sure you will let me. I've been nice so far, I hope. So I'm going to change this now. It was 200 divided by 5. It'll give me 40. The 5 theta will become theta. And now the multiples, instead of adding multiples of 360, 360 divided by 5, it will be now 72. So 72n. So we're ready to pick up our solutions. And the interval we got is 0 to 360. So let's pick up solutions for this particular question. From the first family, 60 is okay. And there won't be anything else because we're adding multiples of 360. So there's nothing else from the first family. From the second one, 40 is okay. And now we need to keep adding 72s. So adding another 72 will give us 112. Adding another 72 each hopefully will give us 184. Okay, x5, another 72, 186. Is it 256? 180 plus 70 is 250. 256. I hope I'm not making any mistakes. I should really be using a calculator now. This is for accountants. 256 plus 72, 328, I hope. Or something like that. I think you get the idea. So I hope I haven't made any stupid errors with this. I've done the maths. That's the maths. That's the difficult bit. And I hope you can actually see the power of this particular method when it comes to more advanced stuff. This is not something you can do with ordinary identities or cast diagrams or anything else. This is really, really cool. Okay, so I hope you enjoyed it. I hope you liked it. And who's laughing now? I'm laughing because I finished for the day. It's Friday evening. See you later.